Have you ever wondered how your car's engine stays at the perfect temperature? It doesn't matter if it is a freezing winter morning or a hot summer day. The engine works hard to maintain a steady, ideal heat. This important job is managed by a small but very clever part. This part is called the thermostat. Think of it as a gatekeeper for your engine's cooling system. It decides when to let the engine cool down and when to let it warm up. Its main goal is to keep the engine from getting too hot or too cold, which is crucial for its health and performance. The thermostat is a simple valve located between the engine and the radiator. Its job is to control the flow of a special liquid called coolant. Coolant, which is often a mix of antifreeze and water, travels through the engine to absorb heat. The thermostat's function is to either block this coolant or let it flow to the radiator. The radiator's job is to cool the liquid down before it goes back to the engine. The thermostat makes this decision based entirely on the temperature of the coolant itself. It is a smart, automatic device that needs no computer to tell it what to do, just the heat from the engine. This small metal part plays a huge role in your car's daily operation. Without it, your engine would struggle to reach its best operating temperature. On cold days, it would take a very long time to warm up. This would affect how well your car runs and how much fuel it uses. On the other hand, without a way to control the heat, the engine could easily overheat on warm days. This could cause serious and expensive damage. The thermostat is the key to finding that perfect balance, ensuring your engine is always happy and running smoothly no matter the conditions outside. Understanding how this component works is a great first step into learning about your car. It is a perfect example of a mechanical part that does a complex job with a simple design. It doesn't rely on fancy electronics, but on a basic principle of physics. As we go through the process, you will see how this little gatekeeper opens and closes to protect your engine. It ensures your car is efficient, reliable, and comfortable for you, the driver. It is truly one of the unsung heroes working hard under your car's hood every single time you turn the key in the ignition. When you first start your car on a cool morning, the engine is cold. A cold engine is not an efficient engine. It needs to warm up quickly to run properly. This is where the thermostat begins its important work. In its cold state, the thermostat is completely closed. It acts like a solid barrier, blocking the path for the coolant to leave the engine. This means the coolant that is inside the engine block stays there. It cannot travel to the radiator to be cooled down. This is done on purpose to help the engine heat up as fast as possible, which is better for all its moving parts. By keeping the coolant trapped inside the engine block, the thermostat creates a small closed loop. As the engine runs, it generates heat from burning fuel. Since the coolant is not flowing away to the radiator, it starts to absorb this heat very quickly. The temperature of the liquid begins to rise steadily. This process is like putting a lid on a pot of water on the stove. The lid keeps the heat in, and the water boils much faster. The closed thermostat does the same thing for your engine, helping it reach its ideal operating temperature in just a few minutes, not a long, drawn-out time. This rapid warm-up phase is more important than you might think. An engine that warms up fast performs better. The oil inside the engine flows more easily when it's warm, providing better lubrication to all the moving parts. This reduces wear and tear over the long term. A warm engine also burns fuel more completely and efficiently. This means you get better gas mileage and produce fewer harmful emissions. Your car's heater also relies on this hot coolant to warm up the cabin, so a fast warm-up means you get warm air blowing from your vents sooner on a chilly day. So, while the engine is warming up, the thermostat remains firmly shut. It is patiently waiting, constantly monitoring the temperature of the coolant that surrounds it. It has a specific temperature it is designed to react to, usually somewhere around 180 to 195 degrees Fahrenheit, or about 82 to 90 degrees Celsius. Until the coolant reaches this target temperature, the thermostat will not move. It holds its ground, ensuring the engine gets all the heat it needs to get ready for the drive ahead. This is the first and very critical step in the cooling system's daily cycle of work. The magic inside a car's thermostat is surprisingly simple. It contains a small cylinder filled with a special type of wax. This wax is engineered to do something very specific. It expands a lot when it gets hot. A metal pin is submerged in this wax. As the engine runs and the trapped coolant gets hotter and hotter, the wax inside the thermostat cylinder begins to melt and expand. This expansion pushes the metal pin outward. The pin is connected to the valve that blocks the coolant flow. So as the pin moves, it slowly pushes the valve open, breaking the seal. When the coolant reaches the thermostat's designed opening temperature, the process is in full swing. The expanding wax has pushed the pin far enough to open the valve. Now, the hot coolant from the engine has a path to escape. It begins to flow out of the engine and through the upper radiator hose. It travels to the radiator, which is a large metal device with many small fins. Air moving through the radiator, either from the car moving or from a fan, cools the liquid down. This now cooler coolant then flows out the bottom of the radiator and back into the engine to absorb more heat. The thermostat doesn't just snap open and close like a light switch. It opens gradually, allowing just the right amount of coolant to flow. If the engine is only slightly too hot, the thermostat might open just a little bit. This lets a small stream of coolant go to the radiator. If the engine is working very hard, like when climbing a steep hill, it will get much hotter. In this case, the wax will expand even more, pushing the valve fully open. This allows the maximum amount of coolant to circulate, providing the most cooling possible. The thermostat is constantly making small adjustments to keep the temperature stable. The process also works in reverse. If the engine starts to cool down, for example when you are driving downhill, the coolant temperature will drop. As the coolant passing the thermostat gets cooler, the wax inside the cylinder will start to shrink and solidify. This allows a spring to push the pin back into the cylinder, which pulls the valve closed again. This might close the valve partially or fully, depending on how much the engine has cooled. This constant dance of opening and closing is how the thermostat precisely regulates the engine's temperature, keeping it in that perfect sweet spot for optimal performance and health. The most obvious and critical reason a thermostat is important is to prevent the engine from overheating. An engine without a thermostat would let coolant flow to the radiator all the time. On a hot day, this might not be enough to stop it from getting too hot under a heavy load. A working thermostat ensures that when the temperature climbs too high, it opens fully to maximize the cooling effect. By keeping the engine from overheating, the thermostat protects vital components like the head gasket, pistons, and cylinder head from warping or cracking. This prevents catastrophic engine failure and saves you from incredibly expensive repairs. Conversely, the thermostat is just as important for helping the engine warm up quickly. If a thermostat is stuck open, or not there at all, the engine will take a very long time to reach its proper operating temperature, especially in cold weather. This is bad for the engine. A cold engine experiences more internal friction and wear. It runs inefficiently, leading to poor performance and a feeling of sluggishness. The thermostat's ability to stay closed when the engine is cold is fundamental to reducing this long-term wear and tear, extending the life of your engine significantly. A properly functioning thermostat also has a direct impact on your wallet through fuel efficiency. An engine that operates at its design temperature burns fuel more completely and effectively. When an engine runs too cool because of a faulty thermostat, the car's computer might think it is still in its warm-up phase. This can cause the computer to inject more fuel than necessary, a condition known as running rich. Over time, this wastes a surprising amount of gasoline and increases your fuel costs. By maintaining the correct temperature, the thermostat helps you get the most miles out of every gallon. Finally, the thermostat contributes to your comfort inside the car. The heater in your car's cabin works by using a small radiator called a heater core. Hot coolant from the engine flows through this heater core, and a fan blows air over it to warm the passenger compartment. If your thermostat is stuck open, the engine coolant will never get hot enough. This means you will only get lukewarm or even cold air from your vents, which is very unpleasant on a cold winter day. A working thermostat ensures the engine produces enough heat for both itself and for keeping you warm and comfortable during your drive.